Hello YouTube, my name is Waidera and I'll be doing a video on domain-driven design. This is a new series I'm starting. It will be quite an exciting one actually. So I'm going to cover domain-driven design. So this is the first video. It will be more of an overview, and then over the next video I can go into more detail on over the next videos, that is. Anyway, so what is domain-driven design? First, it's a software design approach driven by your domain. An approach of developing software connected to the implementation, that deeply connects the implementation to the core concepts of the business or to your domain. We can go different. The domain, the business, if I'm making, let's say a shopping cart, an online delivery system, that is my domain. So I feel like that's clear. Anyway, so a set of tools that assist you in designing and implementing software that delivers high value, both strategically and tactically. We're going to get into more details on that, what I mean when I say strategically and tactically. What is a domain? It's a specified sphere of activity or knowledge. It's a subject area around which the app has been centered. So like we gave an example with the delivery system, that is what our software is centered on. That is what it relates to. What is a model? We talk about domain model. So it's a selectively simplified and consciously structured form of knowledge. So every model represents some aspect of reality or an idea, so that is of interest to the user. So we need to distill it in a way that we only give abstract away all the irrelevant things and just give me what is relevant to take away the extraneous detail. A good example of this is, for instance, when you look at Google Maps, it gives you just, I think, one common task users use Google Maps for is fast navigation. So it needs to present roads in a human readable way, very clear. Things to do close to you. That's another example. So those are highlighted. We'll hardly care about, we will hardly see Google have the A1, let's say the road naming system that mostly maybe developers of roads would use. That's not of importance to the end user, so they would not use such a name. They would use the normal human readable street names. They would not care whether there is electricity lines passing through the street. That's not details. That's going to be there because the customer doesn't care about it. So we ignore such details and only focus on what's relevant to the user. So an appropriate model makes sense of information and focuses it on a problem. So we are at the end of the day, we're looking to have distilled knowledge so that we are able to, models are the tools we use to deal with all the complexity and all the volume of information we have. All right. So what does the model represent? What are the goals? The model and the implementation should shape each other. Changes on both ends should be reflected. So if my implementation is code, for instance, if my implementation is in code, I do expect that every time I make changes to a model, they are also reflected in the code and vice versa. We don't want a case where they now deviate and there's when you go to read, let's say it's a design doc, there's no resemblance to what is in the code. We need them to be shaping into each other. So that's what that means. The model is the backbone of a language used by all the team members. So when trying to distill knowledge, you are gathering domain experts and developers. In this case, we need to have a common language. For instance, a common case is, let's say, client. A client in software means a service that consumes other service, a software that consumes other services, something like that. But then when it comes to the business expert, a client is the person who's bringing me money, is my customer. So we need at the end of the day to have a common language that we use between the business experts in this case and the developer. So we will talk about this language in a bit. The model is distilled knowledge. I have mentioned that. So these are the goals of having this model. We have two main players when doing this when designing our model. We have domain experts and we have developers. So domain experts, who is a domain expert? As you have figured, there's no such role as domain expert. You've never seen an ad say, we are hiring business experts. There's no such role. So who qualifies as a domain expert? So let me use an example of a restaurant an example of a restaurant. So in a restaurant, when we go to the kitchen, the cooks, maybe the experts, the cleaners, maybe the experts, the business experts, the CEO of a company, of course, is the expert. You need to know your product. When we go to the serving, like orders, the waiters are the experts. When you, like the servers, when you go to, what is this called? When you go to reservations, we have hosts. So see all these different parts of the company, of the business, and we have each one with people who are really good, who are experts at this. In a school system, the administrators may be experts, the cooks in the kitchen. Okay, but that's not the core domain. The teachers are the experts in this sense, the students, because you're building it for them. So look at who you're building it for and who actually interact with your system on a daily basis, and those are the ones you are supposed to get and gather information for, because you're solving a problem for them. Of course, we also need developers, because they're the ones who are going to implement the solution. So these are the two main players. Bring the two together and then effectively create a model that works for so that it implements it. So let's get into design. I mentioned strategic and tactical design earlier when I was defining DDD. So what is strategic design? 3 main things it does. It highlights what is strategically important to your business, how to divide up the work by importance. So we need to know what is a core, what is a supporting thing, just divide them and get to figure out all the relationships and how they interlive with each other, how they're going to interact, which ones are not even going to interact in the first place, but we'll get into that. How to best integrate as needed. So that's another thing. Again, when I was talking about the interaction, that's the integration. The next thing is tactical design. So it's not one versus the other. They both. So strategic is more of the big picture, and then tactical is more of, let's get into the details of this. What are we getting? You get, like, how are we going to actually fine-tune these things? How are we going to actually represent our things? So a focus on fine details and how to represent them. We are going to deal with the domain objects, the life cycle, the representations, abstractions you can use. That is going to be covered when talking about tactical design. All right, so DDD. What is DDD again? It's primarily about modeling a ubiquitous language in an explicitly bounded context. Basically, if that made sense on its own, like if we had previously defined ubiquitous language and bounded context, would have been done with this slide, but I had not, so I'll continue. But that's basically what it is. But once we understand what this is, we can come back to this and get to define it and understand it. So let's use an example of a student of a school management system. We have, let's say, our focus is on the student, things that pertain to the student. One, we need to actually store details on the student alone. That is their ID, their name, their age, whatever is relevant to keep track of, especially so that we can track on its own. We have student subjects. What subjects is this student taking? Are they taking mathematics? Are they taking Kiswahili? Put them all here. Student attendance, that's something we may need to track. Are they present? Are they absent? Are they always late? Of course, these may change in a boarding school, but see, according to the relevance, maybe they are absent because they are sick and they are home. So such things you do need to track. Student class sessions, how many classes do they have? What periods are they busy? Such is something you need to track. Are they in what activity, like if I wanted to get to know what a student is doing, are they currently doing physics, and how can I easily locate them? That is information we would need anyway. We may also need to know the teachers this student is interacting with, who's the class teacher, such information, the extracurricular activities. So all these are things pertaining the student. some may be borrowed, like we may get some details from other places, but all these alone are just things pertaining to the student. We don't have things that may be related more to the class. For instance, what's the windows, which type of windows did you buy for this class? That is something that would be specific to the class and not the student. So in that case, this is the student bounded context. All right, so let's understand what a bounded context is now that I've started with an example. A bounded context, a semantical contextual boundary. Within this boundary, each component of the software model has a specific meaning and does specific things. All right, so we have this boundary, and within this boundary, we have the different things that have their different roles, these components. So these components inside a bounded context are context specific and semantically motivated. So what do I mean when I say that? I give an example of a client, for instance. Let me use another example of subject. I've given an example of class. The details regarding subject at a class level may be different from the details regarding subject at a student level. From a student, maybe I'm tracking all the subjects this person is taking, this student is taking, their score in the different like their performance, their scores, who's teaching them. But then we have, at the class level, we have different students taking different subjects. So we are going to maybe track subjects at a different level. So this is one thing that may be similar, that literally means the same thing, but the different bounded contexts have different interests in them. That's for one, and we care about different details about them, so we're not going to put them together. So that's another example, specific, like there's that contextual meaning to it. Ubiquitous language, so the language used within a bounded context. So I've given an example of subject, so we need to always be meaning the same thing. The language between the developers and the domain experts. Like the example I give on clients, when I say client, the developer should not be thinking a different client, the business expert should not be thinking a different client. The terms should be the same between the business experts and the domain, and they should also be the same in the code. We shouldn't now go and now change to use whole different names. Like, we have already done the naming for you. They should reflect to each other. So it is used in discussion, design, and in the code. That means your classes, your modules, your methods, which will now allow a shorter feedback loop. When I get to a place where I feel like asking, where I need to ask a question, I can easily now communicate with the business expert, and we will have a common understanding of what we're talking about. Unlike where there would need to be translation, or one person is not understanding. So it prevents the development of different languages by both parties, causing a language barrier. So, and also, of course, causing inaccuracies and misinterpretation. So clearly define the meaning of each word and term being used. The bounded context is initially conceptual. The aim is to eventually gain more clarity. So I think that is very clear. So ideally, at the start, we have nothing, or we have so much information that we do need to distill, we need to refine. So at the start, it is conceptual. We really don't have a model that is clear that you can quickly implement. And with time, as we keep having more discussions, with sessions like event storming, which we may talk about later, but these are just ways of now modeling, of distilling our information, getting to know this information from business experts, exchanging, getting clarification, using the language that relates to the business, instead of just being like such things. Then we will, with time, we get there. Because of this, it will transition from being your problem space to being your solution space. So what is a solution? What's a problem space and what's a solution space? Your problem space is where you perform high-level strategic analysis and design steps within the constraints of a given project. So this is literally the working ground. So, and then what is your solution space? It is where you actually implement the solution that your problem space discussions identify as your core domain. So we've introduced a new term there called core domain. Let's check it out. What is a core domain? There will always be many bounded contexts in play. I've mentioned, for instance, one where we would have a student bounded context, and we would have I wanted to go back to the definition earlier. DDD is primarily about modeling a ubiquitous language in an explicitly bounded context. Now, we're modeling the language in this boundary. So I hope that is now clear. I mean, we should be done, but now let's also get to more details of how to go about it. I was kidding when you said we should be done anyway. So there'll always be many bounded contexts. I've given that example. So for instance, if student is the main thing I'm designing, if I've established student is my core domain, and the main reason we are talking about core here is the business can't really focus on everything. We need to, for instance, if I'm making a project, I'm mostly focusing on one feature, I'm mostly focusing on one specific product. So I need to establish what is the main thing here. In a school management system, I'm less interested, for instance, in tracking maybe the source of fire being used in the kitchen. Like, it may be important, but it is not the core business. So it may be more of a supporting thing, or even something we don't really need to track in a system per se. So because of that, we have all these other bounded contexts. So a subdomain is a subpart of your overall business domain. So we have a student subpart, that is a subdomain. We have a class subdomain. We maybe have a teacher subdomain. We have one that tracks subjects. We have maybe one for tracking the library. So we have all these subdomains that all come together to be the school management system. The core subdomain, that's the main focus of the business. I've mentioned why. Supporting subdomain supports the core domain. No generic option is available. So if, for instance, I need some details on the class and there's no mainstream thing that I can easily use, I will need to create something that now helps me. I'm not saying in this case class is less than student, but it's not my main focus. So it is supporting. I need details from it. So I will need to create a whole bounded context and ubiquitous language here, but I won't give it the same focus I'm giving the student management system, the student one here. Bounded context or subdomain in this case. So another one, generic subdomain. This is an easy off-the-shelf options. For instance, something I can think of when it comes to a school management system is maybe a scoring system. We use the same scoring system. For instance, if you're using the Kenyan school curriculum, it's okay, like you really do need to stick to the main one, to the one everyone is using, so that it's consistent. So in that case, we don't really need to create one that is specific to this school, because there's already this solution already presented. So we can use something that's already created by other people. We can buy a common solution. We can use open source if that were a case. But all in all, that's the idea. So we have two different terms, that we have subdomain and we have a bounded context. What's the difference between two? So ideally, like I said, okay, I didn't say this, but ideally one subdomain should be per one bounded context and vice versa. It's one-to-one, really. They're always like, if the bounded context is a boundary, subdomain is literally representing a single logic domain model. They're sort of similar, but just a different way of categorizing it. So yeah, subdomains can be used to logically break up your whole business domain, so that that you can understand your problems based on a large complex project. Again, like the school management system, you get to understand what you should care about more, what you should focus more. Next thing, I'm going to introduce a different term, context map. So this is the integration of the different bounded contexts. I have mentioned that a system will typically have many bounded contexts. So what are their associations when they're put together? Like this integration, what is it called? It's called a context map. So it's as simple as that. we have an example here of now associations with like relationships between contexts. So yeah, context mapping, whatever you're going to call it, but yeah, that's how they relate to each other. So looking at this, I'm not going to dwell on continuous integration. That is more of refining within the one bounded context. But bounded context, names enter, the ubiquitous language, we've established that. This is an image from the Blue Book. So a bit of a history that I forgot to give. Domain-driven design was coined, like the whole idea was brought out by Eric Evans in his book, Domain-Driven Design, tackling complexity at the heart of systems. It was on the first slide, actually, so you can look. I've actually put his book, and then I've also added Vaughn's book and Vaughn's second book that is more of a distilled version of the first one. The whole reason I did this was so that you also can look at these books and go into more details, and also get to, like, it's really, in case you need to even read more about it, then you can go and reference those books. Yeah, so at least you now have the overview. You can now go with, I'm inspired. Anyway, I'll stop being silly. So bounded contexts assess or overview relationships with context maps. That is the context map is what now will hold all the other bounded contexts, and now these are the relationships between the different bounded contexts. The different ubiquitous languages in the various bounded contexts, we need a way to relate with them. Let's look at the real world. We have different traffic laws in different countries. For instance, let me use East Africa as an example here. So Tanzania has a speed limit of 50 kilometers per hour for most of their roads. So when you're coming from Uganda, Kenya, where you're used to 80 kilometers per hour, there's that change that you have to do, whereas they should not unify. These are two different things. One must either conform, or you just have to have a translation layer where you have to be like, okay, when I'm dealing with this, I need to convert to this, something like that. Or where we don't totally meet at all. Anyway, but I'm going to details on explanations on how to go about software, but this may not be specific to the real world. But anyway, that's a good example. Of course, there's also the example of different countries have left-right driving. So when you go to Rwanda and Burundi, you have to drive on the right side, which is not what we are used to most of the other East African countries. So these are differences in the real world that would be now also different in your bounded context, where, like I gave the example of subjects, we have the same thing, but we need different details from it. So how do we interact with it? Do we follow one? Do we have a common one where we both share this, but then why are you giving me details I don't need? That's basically it. So this kind of mapping between the different bounded contexts will depend on different things. You have level of control you have over the other model. If it's something I own, I can easily change. If it's a team I easily work with, I'll have a different associations, like the relationship with them. If it's something, for instance, open source, I may shy off from, I may not trust that they will specifically change to what I want. So because, for instance, open source, it's not like, unlike a paid product where you mostly have a support team that can come and assist you, this is not the case. This is people who are actually working and prioritizing their own work sometimes, which is totally okay. So you can't rely on that. So you need to have a different relationship versus if you're using a product that is supported. There's the level and type of cooperation between teams. This may work better when there's there's the different managers in the different teams, but then there's also the manager of the two managers may be the same. So then they may have a similar system of working or better collaboration, which would be different if I'm dealing with maybe a team from a whole different country, maybe a language barrier, or we just never interact. So that may be a more difficult relationship, and then because of that we may explore different things. The last thing is the degree of integration of features and data. Anyway, so we have different ways we can work together. We can go separate ways. So when working together, what are some ways? One, where there's a shared kernel. In this case, we are totally sharing. We're sharing one specific thing. For instance, if I'm dealing with, I have two helper things for employee. One, there's these two supporting, yes, bounded context, but they're all interacting with the same employee information. Yes, they need different things, but we can keep a system where we have this shared data in the middle that we can keep sharing, designate some subset of the domain model that the two teams agree to share. And of course, for this case, you would need to now make sure that if you're going to make changes, the other team needs to be okay with that. So that's, of course, you can make changes to your own system, but now for the shared code, then you have to involve the other team. Another relationship is customer-supplier relationship. So between teams, this is mostly where there's upstream and downstream relationship. In this case, of course, there can be different challenges with that, where upstream might be very careful to change things to a point where it may slow me down because I'm afraid of changing and affecting you. Or the other case where the down system needs some changes, but will they make the changes in the system? Do I trust that they will make changes that will impact me? So such things, you can maybe have a way of change tracking or something like that. But anyway, so that's another relationship. Some ways you can do this is, for instance, a customer supplier. When the example I gave of having a paid customer, most of these times, a business may have one customer that's really big, and because of this, they may influence or be like, we had an example of a company that wanted their interface wired to look like their product. So we had to totally change a lot of the code on our side, which was okay because they were a really big client. So because of that, then you're okay doing that as the supplier. Of course, it's not the case for the smaller customers. It's not the case for if you're changing the business direction. So these are some factors to check out. Another way, for instance, for normal upstream and downstream relationship is, now every time you need to make changes, maybe have a person from the downstream team come to your team. They can be involved in the discussion so that they figure out if this change that's going to be made is going to impact them. Another way to have a relationship is the conformist model. Literally, follow the leader, conform. You're giving me this, I'll work with it. You've changed this, I will change for that. Of course, it's more practical if the changes are not happening as much, but it's also a very practical model for some reason. But of course, because of that fear, many people shy away from using it. So another way is separate ways. You've assessed the situation. Yes, I need you, but the integration may not be worth it. So I'll just find my own solutions or work with what I have. So in this case, it's a separate ways. We're not conforming in any way. There's no association. Another example, which is also common when dealing with external systems or legacy systems, is using an anti-corruption layer. So create an isolating layer to provide clients with functionality in terms of their own domain model. In this case, it can be bidirectional, where you're placing it, for instance, if it's a legacy system, you can put it next, like you can attach it to the legacy system where everything, like when I'm making calls, I make calls through this anti-corruption layer. It can be on your side as the service that's being built. It can be on both sides, so that doesn't matter. You can implement this using facades, adapters, and translators. I'll try to give an example of this in code so that you actually see. Another way you can work with other people is open host service. This is a protocol where you give access to your subsystem as a set of services. This is most common where I have a product and I need to provide it to many people. So in this case, I'm just going to have an open thing that is open to the public. For instance, if I'm creating a YouTube client that is easily accessible to everyone, in this case, I'll just post it and then people can just easily work with them. Of course, it's important to have something that is easily consumable by other people. So here comes published language. You need a common language for this. You have no business, for instance, presenting like your responses and requests in a form that other people are not easily used to or most people are not working with. For instance, very few businesses are working with XML right now, so it may make sense to maybe lean to JSON or even wire formats like protocol buffers. So something like that is something to consider. So this published language is just a language that now it's a common language for this translation. We're done with strategic design. Let's now get into the tactical design. This is where we'll be zooming into the implementation details using building blocks of DDD. So we're going to cover domain objects, we're going to cover the life cycle, and we're going to cover aggregates. So let's find out what these things are. How do you express the domain? So we express the domain by, first of all, domain objects. We have two domain objects. One is entities. It models an individual with a unique identity whose state changes over time. So two entities are similar if they have the same key. A bit on this. So what's an example of an entity? A student, for instance. An identity can change its attributes but not its identity. So we've said that the state changes over time. I create a student. Over time, I come and update. Maybe I add a session for them. Maybe they start football, so I have to track that they are now playing football. They're in drama, so they're in this extra. I'm tracking all these activities they are also in. As you can see, this state of this student is changing over time. We need a unique identifier for this student. So we can have unique identifiers come in two different ways where the user provides them. For instance, in the case of where, let's use government systems where they now use your national ID, which is a common thing. Sometimes they don't have that information, so give them when you're registering to a system that's not unified to the data they have. So give that, and then they'll create an account for you using your national ID. So that's one example. And then, of course, there's auto-generated one or system-generated ones. For instance, now in a school management system, you may use something like a student registration number that is unique to that student. If the identity changes, it's a new entity regardless of its attributes. So if I have two students with two different identity like registration numbers, those are two different students. They're not the same. But when I look at a student object when it was created and a student when they're being deleted, based on the fact that they have the same registration number, I know that I am dealing with the same entity. The next domain object is value objects. These models an immutable conceptual whole defined by its attributes. So examples of these are things like timestamps, things that you need, things that you need to track either in like as a whole and things that will not be changed. So if I'm tracking, for instance, updated time, I have no business coming and changing that value again, unless like to be a whole different record when I change again. But anyway, so two value objects are equal. Here we check equality, all their attributes are the same. So if I'm, for instance, tracking addresses, and addresses contains maybe PO box, and so I have PO box code and the town and the country. So if I have two value objects with the same PO box code, the same town, and the same country, I know it's the same thing. But if one thing is changed, that's a totally different things. Because of these value objects are immutable, any change makes it a different thing, like I explained. Another thing we're going to discuss here is services. This is not a domain object, just to be clear. It's an operation offered as an interface that stands alone in the model without encapsulating state. So if I have a case where I am, yes, in my bounded context, and I need to work with two different aggregates, instead of, again, we're going to go into aggregates anyway. So in this case, this service can act as a place of working with two different, like for instance, let's say I'm adding a student and also let's leave the school management system, and maybe I'm registering exams where I register at the national level, where I register a student to a specific school. In this case, of course, it's not the same example, it's not the same system, but ideally, I'm just explaining that you would first maybe need to have this, like, create a student and then create a school and then attach this student to the school. If, for instance, the school was already created, you don't have, you just need to assign. So these things are things that ideally would interleave two different not bounded contexts, two different aggregates within this bounded context. This specifically within a bounded context, but it can also be an abstraction. Anyway, you'll see more an example of this later, but something like that now works with different aggregates. I'm going to use aggregates here, but we're going to explain what that is in a few. So in that scenario, then you would use something like a service to abstract it. It's totally stateless, so I don't own this data. I'm more like a scheduler. Do this, and then after this, do this, something like that. Last but not least, we're almost done. So I really tried to make those 5-minute videos. Anyway, so life cycle of a domain object. What is the life cycle? The birth, the life, the death of a domain object. Anyway, an aggregate. So a collection of domain objects bounded by a root entity. So this can be one entity, it can be many entities, it can be many entities and many value objects, one entity and many value objects. So basically, you're now grouping these into things that need to stay. Like, for instance, a student can be an aggregate on its own, but within the student, you're tracking all these other details as you've seen. So in this case, I'm not like, my root, yes, becomes a student, but if I want to make changes around activities associated with the student, then I go through the student ID, something like that. It collects many different domain objects as much as are needed to represent the student correctly. So a bit of things around the aggregates. The root entity, the one I've mentioned, is called the aggregate root. Objects in an aggregate can be treated as a single unit. So it should be a single unit, will be treated as a single unit, and it also always needs to be complete. Access to objects, I'm going to cover more details when I'm dealing with aggregates on their own. I don't want to cover too much on this video. Access to objects in the aggregate root must go through the aggregate root. For instance, if I want to get the activities, I can't directly go and access the activities of a student. I have to go through first get the student, go through the student ID or registration number, in this case, whatever name or whatever you've decided to use as the aggregate root. Transactions should not span multiple aggregate roots. So if I shouldn't be in a case where I have a transaction that passes through a student and then goes to the class aggregate, that should never be the case. So I feel like that's clear. So a question for you here is, how do you determine an aggregate root? Also a bonus question for when we were dealing with relationships. Another question I want you to ask yourself and maybe go and find out more. I will cover later, but I wasn't going to cover in this session, is how do you determine which relationship you're going to pick out for your bounded context? What do we go with given all those options you have? So that's something to look at. Anyway, let's cover another domain abstraction. This is called a factory. They abstract away the creation of aggregates involving creation of new objects or reconstitution of new objects. What do I mean when I say this? Sometimes when creating an aggregate, it may be interacting with different DBs. Let's say, for instance, I'm looking for uniqueness. I need to check that this is something that's not there before. So because I don't want these details that are outside, for instance, interaction with databases, with files, maybe other APIs, that is data, that is information outside my domain knowledge, outside the domain specific interests. So in this case, I can abstract it away using something called a factory. So this is in the creation of new objects and also in the reconstitutions of new objects. Why is this still considered creation? Because yes, you're fetching something from the database, but you're creating a whole new model in a sense. So it is still something that exists, but it is reconstitution. That may be confusing, so don't focus much on it, but think of it as how you create new objects. Lastly, repository. These abstract away the retrieving of existing objects. Everything after creation basically will live here. That means the retrieval, the updates, the deletion all go here. And because of, you've seen the reconstitution was considered, like when I mentioned the reconstitution, it's something we're probably fetching from a DB and then recreating or remodeling, representing. So in this case, sometimes you'll find companies or people making the decision to put the two together because they sort of they can work together, plus factory only does the creation. So if you're not really having a lot of the create things, you can put them in the repository too. That's something some people do. So it's totally up to you and your team's choice on this. The two can be put together. So that's just something to know. Another thing to know, only one repository per aggregate root. Don't have a case where you have an aggregate root, like one aggregate root, for instance, student, but different repositories for this. That shouldn't be the case unless you go back to the drawing board and maybe see that there's an aggregate, that something that you would have made an aggregate but didn't. After reconsideration, maybe you can do that, but then it's already an aggregate. Then now create a repository for it, but now don't have the case where you have two repositories attached to one aggregate. All right, so just one last image before we go. Domain objects and domain abstractions. So we've looked at services, how we express our model. We also express our model with entities. I explained entities. We also express our model with value objects. This image again is also from the Blue Book. That is by Rick Evans. Check it out. It's the DDD Bible. Anyway, entities access with repositories. I've explained that's what repositories are for, fetching things that already exist. Another relationship we need to check is between entities and aggregates. So entities maintain integrity with aggregates and they act as a root of aggregate. So ideally, if you have many entities within an aggregate, you need to choose the one that will be the root, so that everyone can, like anyone trying to access the aggregate, can go through this aggregate root. What's another thing? Factories and entities. Factories are encapsulate the creation of entities and aggregates. So as you can see that, so aggregates, entities, and value objects are all encapsulated using factories. Aggregates access with repositories. And that's it, actually. I thought to mention that before we end. And that's it for this video. Check out other videos in this channel and look out for more videos on this. This was a long version of it, but I felt it was important to cover as much as possible to give you an overview. But then we will go into more details in upcoming videos. Until next time, I am Waithira. Bye.